Hello, everyone. A very warm welcome to your own Silicon Valley Tech Talks show, your one stop place to learn about technology trends and insights directly from the leaders. I'm here at ARM's campus today in Silicon Valley. ARM is industry pioneer in designing and licensing compute architectures. The technology is crucial to tech industry as it enables billions of devices across range of applications including mobile computing, automotive, Internet of Things, data centers, and you name it. We're fortunate to have Ami Badani as our guest today. Ami is Chief Marketing Officer at ARM. We'll talk to Ami and learn about how ARM plans to address challenges posed by AI. We'll also learn about strategic direction of the company in years to come. So without any further delay, let's go and talk to Ami and learn from her insights. Hello, Ami. Welcome
Hi,
to the
Faisal.
show. How are you doing today?
Good. How are you?
Good, good.
Good.
Thanks for having me here.
Yes. No, happy to be here with you as well.
Cool. I was telling the audience in the intro part how ARM has created a tremendous impact on the tech industry last few decades with their compute architecture innovations. Now, tell us a bit about the future direction. What are some of the top strategic priorities for ARM in next 2 to 3 years? And what are some of the trends and opportunities you are really excited about?
Yeah, good question. So I think most people who don't know about ARM, we're a compute platform. We've been around for quite a few decades, but I think one of the important things is we're ubiquitous across every platform, every connected device. In fact, I don't think most people realize, but we touch 70% of the world's population. So we're sort of in everything that you touch, but you probably don't even realize, from your smartphone to your smart thermostat to whatever it is at your home. So from a strategic priority perspective, there are a couple different things that we're focused on. One is most people think about ARM and they think about the mobile devices. That's sort of the origination and the roots of the company. But we've actually diversified quite a bit outside of mobile devices. We're in automobiles, we're in data centers, we're in everything from an edge connected device. So diversification is now part and parcel of our strategy. It's not just about mobile, but it's about how do we really power the compute platform for all these devices. So that's one. AI everywhere is another big strategic priority for us. So what we believe is, and I'm an AI optimist by nature, but I believe that everything is going to be AI enabled in the future, which is really a great tailwind for us, because you think about things like drug discovery with AI, or tutoring, education accessibility in sort of the remote corners of the world that's going to be enabled by AI, or AI agents for financial advisors. All of that needs a compute platform. And that's going to be really run on ARM, whether it's in the data center, down at the edge. AI everywhere is really what we believe, and ARM's at the core of that. Third is really about power efficiency. So if you look at kind of the DNA of the technology of ARM's compute platform, it's really about power efficiency. We are the most performant and power efficient compute platform on the planet. And so we can talk a little bit about what AI is driving in terms of the energy demands and how much it's taxing the energy infrastructure. But that's a key part of our value proposition, is really being the most power efficient compute platform on the planet.
You touched on data centers and AI. With the AI scale and need for these big data centers, which is like data center size growing, right?
Yeah.
With Gen AI models, etc. Uh, there are power and energy constraints, and there is a broader realization in the industry that we do need groundbreaking innovations in power efficiency when it comes to compute platforms. So how are you specifically planning to address this power efficiency problem? If we could go a little deeper into that.
Yeah, and I came from the data center background back when I was in Nvidia, so I sort of saw that transition, especially leading up into the ChatGPT moment. But if you sort of look at, I was reading a study that the latest GPT model, ChatGPT model, consumes 50 kilowatts of energy. So if you think about that, that's 2% of the electric grid today, and that's just on training that's done today. Now you look at kind of the next version of GPT, which is all about reasoning. They want to train it every week versus every few months. And the amount of energy consumption that's required and the tax that it will put on our electric grid, I mean, you're talking 2, threefold in terms of energy consumption from what you see today. So there's lots of optimizations that you need to do on the software, on the silicon, on the components like, whether it's optical infrastructure, whether it's liquid cooling, whether, there's new forms of energy consumption that you need to think about that we don't even know exist today. But really, a big part of the energy consumption is on the chip. And so when you look at ARM, that's where we really play. So the energy consumption of a server in a data center, largely that's consumed, the energy that's being consumed is in the chip. And ARM is critical in that infrastructure. So if you think about our compute platform and the power efficiency that we provide, if you're able to use a more power efficient chip, then you're able to then save power in the server itself. And you need, X amount of servers to be able to train these AI models. So you can just imagine how much energy we're able to save. Now, what we're seeing is probably likely going to happen is that most people are going to use that power savings and power, extra forms of compute to be able to really move faster with AI. So that's what we believe will happen. But ARM is really focused on the power problem and trying to solve that head on with really focus on the chip itself.
You talked about ARM's evolution from mobile computing to data centers. And we just talked about the power challenge there. I know that ARM is also seeing growth already in the data center segment. Apart from this power value proposition you talked about,
Yeah.
what are some of the other traits of data centers requirements which make ARM's product more appealing for data centers in future? In other words, why do you believe you will continue to see growth in future as well in data centers?
Yeah, so I really look at data centers in two very simplistic segments: general purpose compute and as a companion to an AI accelerator. If you look at general purpose compute, that's sort of ripe for innovation. And we believe that an ARM-based platform, and we partner with many of the hyperscalers and many large companies to really provide ARM-based CPUs that then allow customers to run general purpose compute workloads. That's, a simple database or something like that. Now, if you look at the other segment of the market, this is the companion to an AI accelerator. And you look at sort of what you need for a companion to an AI accelerator. It's super important to have a CPU head node in addition to an AI accelerator because you need sort of the both pairing to do things like memory, to have fast interconnect, to actually run single-threaded processes, software on top of the CPU itself. So you need a good pairing of both the CPU and an AI accelerator. And that's really where ARM fits in, because if you look at the ARM design and our compute platform, it's really focused around flexibility. And so you think about where the world is moving. The largest companies want to become vertically integrated. And what that means is they want to be able to control both the software and the hardware. In fact, if you look at probably a decade ago, that didn't exist. You had hardware companies and you had software companies. That world is now merging. And the reason for that is that most people want to have control over the software stack. And in order to provide differentiation of the software stack, you now realize what you need to do on silicon to be able to enable that. So you're seeing a lot of vertically integrated companies, from the software all the way to the silicon itself. Now, in order for companies to really advance and create their own silicon, you need a flexible compute platform to pair with the companion accelerator to really drive the future of AI and whatever these companies want to do for differentiation in terms of software. So that's really what ARM provides, is the flexibility to be able to design your own custom silicon. And whether you want to do things on the board or off the board, ARM sort of allows a lot of customization, which other companies don't provide in terms of its compute platform. So we're working with, as I mentioned, some of the largest companies to provide that flexibility and performance and power efficiency. So a good example of this is Grace Blackwell, Nvidia's Grace Blackwell, which is well known. And Grace is actually based on ARM for exactly that reason. You're able to have fast interconnect to the memory. You're able to have a flexible compute platform, and you're able to run some of the software specifically on the CPU. And if you think about kind of the macro point, most people think about an AI workload and they think all you need is a GPU, but it's in fact the CPU paired with the GPU that's really powerful in terms of that architecture. If you even look at sort of the hard math is done on the GPU, which is super valuable, but 80% of everything else is really done on the CPU. So you need a flexible compute architecture on the CPU side paired with the companion accelerator to really drive the advancements of what we need in AI.
So let's talk about device side of things.
Yeah.
AI is expected to change the device side of things as well, whether you're talking about smartphones or personal computers. We are already talking about on-device AI with inference use cases, etc. How are you planning to play a key role in driving that change on the device side?
Yeah. Yeah, good question. I think, again, back to my earlier point, most people think about us as mobile device, but we're in wearables, glasses, whatever's to come in terms of different form factors on the edge. I reflect back, the last couple years has really been about training in the data center. And this year, you're really seeing inference on edge devices. And ARM is critical in that because, again, back to flexibility, back to power efficiency, those are key constituents of why you need silicon on the edge. I mean, a lot of the silicon on the edge and in these wearable devices are becoming miniaturized, and power is so part and parcel of that equation. And so ARM is sort of at the heart of that. In fact, many of the devices that you wouldn't, that you hear about today are all actually based on ARM.
So, are there any new innovation opportunities in the compute architecture domain which new researchers, entrepreneurs can work on? Or perhaps there could be opportunities for wider collaboration at the industry level to accelerate those innovations?
Yeah, that's a good question. So I think in order for the industry to move forward in terms of AI advancements, you need the collaboration of the entire industry. So whether that's at the chip level, the systems level, the platform level, at the software level, you really need those innovations in collaboration. I think today what you're seeing is companies focused on one small piece of the problem, but I think what you need is the industry to come together to solve it from a platform perspective. And once you solve it at a platform perspective, you're able to go much faster. So I believe that there's going to be lots of advancements, whether it's, at the infrastructure layer, the software that runs on top. There's just going to be a number of opportunities for the industry to collaborate together on kind of the future advancements of what's to come.
I mean, you are a great example of someone who has excelled in the large companies and had awesome career, Cisco, Nvidia, now ARM. Would you share any advice or guidance for new professionals who are starting their career?
Yeah. Uh, I think a couple things that I think about is sort of a reflection of my career. I think one of the big things is take calculated risk. So I'm a big believer in sort of taking these calculated risks, understanding where you succeed and where you fail, and fail fast, move forward, but learn from your mistakes. That's sort of kind of part of my philosophy, and a lot of the folks I hire around me are very focused on that sort of the growth mindset, I like to call it. Secondly, I think it's a lot about sort of sitting in other people's shoes, having that empathy, and just I'm a big believer in relationships and being able to understand the other side. So I've done a lot of things in my career, whether it's investment banking or product management, now marketing, running the marketing function at ARM, and I've had the privilege of being kind of the seat in many of these different functional areas. And I think you just have empathy for different people's roles and responsibilities, and you sort of meet people where they're at. So I think that's one of the things I would recommend is have breadth in your career, and do as many things as you can, learn as much as you can, and then figure out what gets you excited every day. And then I'm a big believer in being technically curious. So I'm constantly reading things like academic papers, or listening to podcasts on my drive to work, or reading things on LinkedIn or X, or figure out your favorite platform, and just immersing yourself, because there's so many things that you learn about just by reading the news every day, or different influencers, or what have you. So that I sort of really love that part of being technically curious, because I think that makes you better in whatever role you want to do in the future.
Well said, Ami. Thank you so much for participating in our show. I'm sure audience learned a lot from your insights.
Thanks for having me.